Welcome. So in this part of the lesson, we're going to be answering this question before us. Let's give it a read and see how we go. It says, show that the solutions of the equation this are rational for all rational values of m. So what we need to do is we need to show that the solutions to this are rational. Now let's break down what this word means. What it means is that x-intercepts exist. So in other words, we have some amount of x-intercepts. So that means either the discriminant is equal to 0 or the discriminant is greater than 0. Either of those, because either you have one solution or you have many solutions. Now this is an interesting type of question because it's a show that question. So we want to show that the discriminant is, we want to show that the discriminant, well, let's see if I can spell correctly, the discriminant is greater than or equal to 0 for all values of m. That's that last part of the question. So show that are rational for all the rational values of m. So this is what we're trying to do here. We're trying to show that the discriminant is greater than or equal to 0 for all values of m. That's what the question is asking us to do. Let's begin by just finding out what our discriminant actually is. So we're trying to figure out what A is, what B is, and what C is. A is going to be 3. My B, remember, it's just whatever is in front of X in this case. So what is in front of X is m minus 3. So m minus 3 is my B value. Then my C value is the constant at the end. Do you see here, it's negative m, and that's fine. It's just negative m there. So my discriminant is equal to b squared minus 4ac. Then we keep on going here. I'm now going to sub in my values. So my discriminant is equal to, well, b squared, that's going to be m minus 3 squared minus 4, 3. Then I put a minus m in there. Then I need to expand this out. Remember, you square the first term. You multiply these together, then times it by 2, so that's negative 6m. Then you square the last term, so negative 3 squared is 9. Then we keep on going here. Negative 4 times 3 is negative 12, times negative m is going to be plus 12m. Then I have this and this, they are like terms. So that means my discriminant is going to be m squared plus 6m plus 9. So there's my discriminant. What we want to figure out is this always greater than or equal to 0? So if you wanted to, there's more than one way of approaching this. We could try sketching this thing. So I could try sketching my discriminant against the m value here. To do that, I'm going to have to find the m-intercept. I can factorize this thing right here, can't I? Hopefully you can immediately recognize that this is a perfect square. This is going to be m plus 3 squared. If you can't recognize that, that's fine. You're just going to have to take an extra step. My product would have to be 9. My sum would have to be 6. What are the two numbers? So what are my factors that can multiply to get to 9 and add to get to 6? It's 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. So that means it's m plus 3 squared. It's a perfect square. Let's think about what a perfect square looks like. So in this case, it's been moved 3 to the left. It's going to look like this. Okay, this is very important, everyone. What do you notice here? Hopefully what you notice is that my delta, or my discriminant, is always positive. Do you see how it always exists above my m-axis? Regardless of what value of m I put in, my discriminant is always going to be positive. So m plus 3 squared is always going to be greater than or equal to 0, always. It's always going to be that. So that means my discriminant is always going to be greater than or equal to 0. Another way to think this through, if you can't recognize that this is always going to be greater than or equal to 0, just think about m plus 3 squared and thinking about putting in a really negative number. Let's put in, I don't know, negative 6. If I put negative 6 into my m spot, I'm going to end up with negative 3 here, right? Well, even if this is a really big negative number, I'm just going to square it and it's going to become positive. That's why I'm always getting a positive out. If I was to put in -3 into my answer here, so -3 plus 3, well, that would be 0, and that's how I could get a 0 answer out there. But at the end of the day, what you need to recognize is this. This is the important part right there, that I'm always going to be greater than or equal to 0. So to finish this off, I'm going to say, therefore, the discriminant is greater than or equal to 0 for all values of m, and then I'm going to add it on as the discriminant is a perfect square. And that is just a nice little summary. So the discriminant is greater than or equal to 0 for all values of m, as the discriminant is a perfect square. And you can see the working out there. Before we finish up this video, I might actually even show you what this looks like on Desmos, just to get a deeper appreciation for it as well. So there's my answer. There's my working out. This is a show that question, so it's important that you can do show that questions. You don't leap right to the answer. You kind of just work it through logically until you get where they wanted you to go. Let's have a look at what this would be on Desmos. So what I'm going to do, if this wants to work for me, I'm going to graph this on Desmos. So 3x squared plus m minus 3x minus m is equal to 0. I'm going to sketch it on Desmos. And if we've done it correctly, what should happen here is that I should always either get one solution or many solutions. So let's come down here. Here is Desmos. So I have graphed it, 3x squared plus m minus 3x minus m. Here it is. Whoops. When I change the value of m here, do you see I've got two solutions, two solutions, two solutions. I have one solution at -3, just as we saw over there. When m is equal to -3, I have one solution. And then I have two. There's never a value of m for which this thing has no solutions. It's always touching the x-axis. Okay, that's how that works, everyone. A tricky question there. Hopefully it makes sense. I'll see you later.